Hi, my name is Mohit Sarveiya. I'm a GDE for Kotlin, and I'm going to present to you about how to write compiler plugins with Arrow Meta. So in this presentation, I'll go over, the features this library provides. I'll provide you with simple examples on compiler plugins and how to test them. We'll also look at how to make IDE plugins and so let's start. So there are two things that motivated me to look into this library, and one of them was how do I build tools with Kotlin, like build compiler plugins. And this library provides you with a very functional way and provides you with a nice API to build tools. And also wanted to this library also provides you with introduces functional programming concepts such as monad comprehensions, lensing, etc. at the language level. Makes it easier to use those features that Arrow provides. So let's look at how the Kotlin compiler works. So you write your first, Kotlin compiler, the compilation process is broken down into different stages. First, you write your code and then it parses this code and transforms it into an abstract syntax tree. And it's a structure that it could work with. So each element in this tree represents some function, some class that's part of that you wrote in your code. So after it has, created this tree, it goes into the analysis phase where it provides semantics into this tree based on the Kotlin language. And after providing semantics to each of the nodes, it goes into the type checking phase, resolution phase, where it provides type information on the types that you use in your program. And it will basically check if you're using them correctly. So if you're not using types correctly, like it will highlight that and you'll see an error like in your IDE informing you that you're doing type comparison incorrectly, etc. So after type checking is done, it goes into last phase that it goes into is the code generation phase. So Kotlin 1.4 has a new backend, the compiler has a backend, it has intermediate representation. So it transforms your code into this IR and allows you to target different platforms such as JS, JVM, and native. So after you target one of these platforms, your compilation process is done and you could execute your code. So those are the different steps that the compiler goes through to execute your code. So the library Arrow Meta supplements the compiler and allows you to hook into these different compilation phases. So Arrow Meta, this is a library that was introduced last year, I believe. So it has an API to hook into the compiler, and so at each step of the compilation process, there was a byproduct, there was a result. So in the parsing phase, we had the result was a tree. And this library allows you to hook into that. This library allows you to hook into the resolution phase. And let's look at how that works. So we started off with some code that we wanted to compile, and we parsed it into a tree. And what this library allows you to do is that it allows you to search this tree using a DSL called quote templates. It allows you to search for a node, and it allows you to transform one of the nodes in this tree. So it allows you to transform a class, a function that you wrote in your source code. You could generate code. So then it goes into the type checking phase, and what this library allows you to do is that you could basically hook in your own custom type checking logic that you want for your own custom types. You may want to do some special transformations in your custom type checker. So this library allows you to do that. It provides an API to do this. And also it provides utilities to hooking into IR. And So it has a lot of functions to hook into this. So those are the different ways that this library allows you to hook into the compiler. Now let's look at some examples of compiler plugins. And I'll show you different, very simple examples, and it will help you to familiarize yourself with the library. So start off with the most simplest example that we could think of, which is the Hello World plugin. So there are two steps to writing a compiler plugin. The first step is to first create your compiler, your plugin itself. Specify the logic of what your plugin will do. The second step is to register your plugin, and you could register multiple plugins you want. So let's look at these two steps. Suppose I want to write a very simple plugin where I have suppose in my program, I have a main method that's calling a hello world method. And I want to generate code. And I want to generate code, which is this greeting. I want to generate this greeting, hello, droidCon EMEA. So how do I go about generating this println statement? So the first thing that you want to do to create your plugin is to create a variable called hello world. And it says meta.hello world. So it's an extension property. And meta is an interface. And what's special about meta is that it provides you with information about the compiler, provides you with the context that allows you to configure what you want your compiler plugin to do. So the type of this variable is called CLI plugin, which is a type alias. CLI plugin stands for compiler plugin. So this type alias underneath the hood is basically a type alias to a plugin object. And the plugin object is what you're basically creating for each of your plugins. So how do I create this type? So the plugin object takes in the name of your plugin, and it takes in a Lambda block, which is called meta, in which you will specify something called extension phases. That's another way of saying, that's a way of saying like, what are different ways that I want to hook into the compiler to do what I want. So first thing I'm going to do to create this plugin object, I'm going to name my plugin Hello World, and I have my Lambda block, which is my meta, basically my meta argument that you see here. So now I have to specify what I want my compiler plugin to do. So this may look kind of weird because in here, I'm actually creating an object, but internally, the way it creates this object is that it uses this operator underneath the hood, which creates your plugin object for you. The nice thing about this API is that it looks very much like a DSL-like API. And it's good to see how like you create DSL like really nice APIs, and they do a really great job of creating a nice DSL-like API to create compiler plugins. So I'm creating this plugin object right here. And then how do I hook into the parsing phase, right? So I'm going to call my meta method, and inside of there, basically, I'm going to list my what's called extension phases. And there are many different extension phases allow you to hook into each step of the compilation phase that I spoke about. So what I'm going to do is that I'm going to use a quote. This is called a quote template. It's called name function, and this name function method allows me to search for all functions in my source code based on some criteria. So I want to search for a function in my source code whose name is hello world. That's what I'm doing here. So there are different types of quote templates. There is a named class. You could search for classes. You could search for any type of properties that you want, anything in your source code. And all of these functions, they all have a common pattern to how to their signature. They all have a name. It's a name of the node that you want to search for in your AST. And they specify a Lambda block in which you could specify what you want to do when you have found that element that you're looking for in your source code. So after this plugin, it finds the function, it gives it to me. It gives me the KT named instance, an instance of that function that I'm interested in, and then what I could do is apply a transformation. So I found the function, and I'm going to apply a transformation, which is to replace. So transform is an object underneath the hood, and it has a lot of methods that we'll look at: remove, replace, that allows you to do transformations. And let's look at, suppose I want to transform this method, and what I want to transform it to is to have a greeting, a print line statement like this. So what the function should be, I have defined it in a string template. So what the library provides me is basically what the library provides me. As you can see, I have the string template. I'm doing dot function dot synthetic scope. So those are extensions on a string. But what they do is that they allow you to convert your string template into objects. So everything here like will be converted into a KT type object, and allows Error Meta to work with this, to inject it, to update your AST. So that's the plugin. It looks very simple. I basically is searching for a function and transforming it and adding this print line statement in there. Next thing, the last step, is to register my plugin. So the way you do that is that you follow this pattern for all your plugins with this library. You inherit a meta class, and what it has is a method called intercept, and what it returns is a list of plugins that you want to register, which is, in my case, only one plugin, the Hello World plugin, but it could be any number of plugins you could want to use together. So when I build like my plugin in the IDE, and when I build it for JVM, is going to output a jar that I could, use on my client code. So the way you include that jar file is like this: you specify a compiler argument, and you include that jar file. So after you do this, and I run my program, and I'm going to click on that play button and run it, you'll see in the console it will say "Hello World droidCon EMEA." That means that it has added the print line statement, and you're seeing the result. So that's a very simple example of how to write a simple Hello World compiler plugin. So what happens is that this code gets transformed into this tree, and I'm able to find the Hello World method in there, apply a transformation on it. So this tree is immutable. So it basically applies a transformation to it. So it goes in there, and then it filters it. That's what my quote template was doing. So that's how that plugin works. So let's look at a little bit more complex plugin for logging. Suppose that I had a use case where I have a method that does some calculation called calculate, and this could be something more complex than what I have. And suppose you want to figure out how long it took to execute, and suppose you wanted to generate some code to figuring out how long it took to execute. We also want to only figure that out based on an annotation. So suppose I created an annotation called debug log, and everywhere I give that annotation to, I want things to be logged out in the console on the execution of that method. So how do I create a plugin and generate code to do that? So this is the code that I want to generate it. And here, what I have is I have my original operation that my function will perform. Some calculation, could be something complex. And around it, I want to generate some code, which provides me with some logs. What function am I calling? What's the argument is? And then I'm going to specify the start time. So this is to do the calculation of the execution time. And then I'm going to call my original function body that I had. And then lastly, I'm going to figure out the time it took for that function body to run. And then I'll log out the time it took to run that function body. So there are ways that you could do this, other ways you could figure this out, but I just want to illustrate this in the simplest way. So and then the function will return the result. So how do we generate this time calculation and logging code? So to do that, I'm going to I'm going to hook into the parsing phase of the compiler. So this function will transform into this node. And I want to be able to find a function which has this annotation called debug log. That's my way to filter and find a function in the tree. And I want to be able to modify it and add the logging statement, generate that code. So let's look at that. So in a very similar way, I'm going to add debug logs. I'm going to basically create my compiler plugin the same way that I did with Hello World. Name of it is debug log. I have my meta method in which I specify extension phases. And the extension phase that I'm using is called name function, just as before. And I'm going to find a function with a particular criteria. And I'm going to get it back. That's what the type C will be. So how do I specify how to find a function which has particular annotation? And I create an extension to do that. I create an extension because it makes it look cleaner. So the extension is on kt name function, and I want to match a function that has one int param, has a long return type. Now this could be something, you could make this to be much more general than I'm making it. I did this because of simplicity. But it could be something. You could match a function that has any number of params based on like your use case. So, and last thing, you want to check whether it has an annotation of debug log. So, how do I figure out whether it has an annotation? So the way you do that is that I made an extension here. I give this extension all the annotation names that I want to match, that I want to find. I basically convert that into a set. Then I define this function here, which basically looks at the reference name of all the annotations that are already applied on the function, and it matches the one that I'm looking for. So the way I do this is that I apply this function to annotation entries. Annotation entry is basically each of the annotations that are on the function right now, and then I apply this predicate to it. So this function here, this extension figures out whether a particular function has an annotation that you're looking for. So this is my validate function method. This is a way for me to figure out in the tree, I want a function with this criteria. And then what I'm going to do is I'm going to transform it. And the way I'm going to transform it is by doing a replace on it. And what I want to do is generate the code to add basically the logging statement. So the way I did that is I specified a replace method, and the replace method, what it has is a function name. So first thing I'm going to do, I'm going to grab all the information that I need on the function. So I got kt name function provides me with an API to do this. I pull out the function name, all the parameters that are on there, and the name of the parameters and the body, the current body of the function, the logic that you have defined. So then I'm going to have this function return in a string template the function that I want to generate. So I have my function with the function name. I'm going to have my logging statement right there on what the parameter is currently. Then I have my start time. Then I have my current function body. And then I'm going to do the time calculation, how long it took to run, and I'm going to log that out. I'm going to log that out to the console. And then I'm going to have the return the result. So this string template defines what my function should look like, right? What I want to, what my goal is. So this thing returns a function. Obviously, I need to convert it to something that our meta could work with, right? So in order to do that, there is an extension on a string that this library provides called function. And basically, it takes whatever string template that you have, whatever the string template could have expressions, etc., and it converts it into a type called named function that it could work with. So this is a simple example of writing this plugin for logging, and it's applying a replace transformation. So then, lastly, also, just as before, I want to register this plugin. Again, I could have any number of plugins that I want to register here. I could return a list. So when I run my plugin, what happens? So I have specified a function here. I'm calling it in my main method. And when I run it, you'll see in the logs right there that it will log out how long it took, 36 milliseconds, and what parameter I gave, n equal 10. So this is useful if you want to, like, you have mappers or reducers in whatever architecture you're using, MBI for example, and you want to see how long they took to execute. And you could also like make this as general as possible than I have here. Just wanted to illustrate just mechanics on creating these plugins. So the question is, how do I test this? So it's more important to test things, right? So our meta library provides you with a lot of modules that provides utilities for, as we looked at, compiler plugins, and it has a meta testing module, which has testing utilities. And let's look at how to test it. So first, in my test, I'm going to specify the source that I want my test to act upon. And this is my source, similar to what we saw before, what I had. You basically have a debug log on the calculate function, and then you specify what your expected outcome is going to be. So this string template also has an extension that I'm calling on that gets converted to a source type. This is provided by the error meta library. So this is what I expect my test to do, to generate this code. And I'm going to specify this in a string template again, and this will be my expected output. And I want now to be able to match this source here to this expected output. My plugin, I'm going to give it that source and see if this is the expected output that I get. So I'm going to define a function a test to do this. So there's a test utility that this class has called compiler test. And what it allows you to do, allows you to set up the scaffolding for your test. So I'm going to specify the plugins that I want to run in my test, could be more than one. And then I'm going to specify the code, the source that I want it to act upon, which is I supply over here. Then I'm going to specify what the expected outcome that I want it to be. When I have specified this scaffolding, this compiler test class, I need to run my test. The way you run it is by calling a method that it provides, that utility called assert this. As you can see, it runs your test. And then you supply it to assert this, your compiler test class, and it runs your test. Well, the question is, how does it run your test? So the way it does it is that this is my source. And what it does is that, so when you run your tests, error meta provides you with really great logging on what's happening underneath the hood, and it allows you to debug things. So it takes basically your source and it converts it into types. All expressions and everything gets converted into a particular type. So you can see here, converted this source that I provided to different any annotations I had, etc. And then it applies does analysis on it, and then runs my test, and you'll see the result of what my plugin outputted. If there are any issues, you'll be able to see from this source, like what went wrong, what did it generate, and it will inform you whether your test passed. So this is how you write test with the error meta. There's a meta testing module to do this, and so now let's look at how to combine transformations together. So far we looked at two simple examples. We looked at way to test them. We looked at the mechanics of writing your plugin, and the other way to write compiler plugins is more of an OOP approach, object-oriented approach. But this is a little bit of a functional approach. They provide you with an API to write your plugins in a little bit of a functional way, cleaner way. So let's look at how do you combine transformations. We looked at how to replace transformations. Let's look at a remove transformation. So, when I wrote the plugins that I wrote, the way we found elements were we found a function that we wanted to do a transformation on. We could also find classes, objects, etc. So suppose I want to do a remove transformation and remove this greeting from my function. So similarly to before, I'm going to define my plugin object, And in the meta method, I'm going to say find a function which has this name hello world. And I want you to, when you have found it, I want to do this transformation called remove. I'm going to remove in this function, I'm going to remove this expression over here. Expression in C is an extension that this library has, and it's a method that allows you to convert that string template into something that Aromata could work with. So that's what I'm doing here. When I run this plugin, you'll see that, when I call the hello world method now, nothing gets printed out in the console. So that's how, that's a simple replace transformation you could do. Now let's look at generating new sources. How do you generate source code like in a separate file? So suppose you had a data class, user data class, and you want to generate an adapter for it to serialize and deserialize. You see this in like the Mashi X adapter that was released. You see this in JSON adapters. How do you do that with Aromata? I'll provide a little simple example. So suppose I want to generate this adapter in a separate file. So how do I do that? So similar to before, the same mechanics. I'm going to name my plugin, and I'm going to specify what it's going to do. What it's going to do in this case, first time you're seeing a new code template, class declaration. I want you to find the class declaration where the class name is user. So this could be something much more generalized. This is only for simplicity that I filter for a class named user. And then I'm going to supply a transformation on it. I'm going to say generate new source code, and I'm going to say this is the source code that I want to generate. Now you could add in logic for what deserialize and serialize should do based on the information that you get about this class and what information that you have. So you could pull that information like from this Lambda block provides you with the instance of that class, of that KT class. So then I'm going to convert, and so I'm going to use this extension called file to specify which file I want to place this generated code in. So this is a simple example of using transform.new sources. So when you run this, you'll see in a separate generated file the source code that you have there. So this is something simple, but could be more complex. So lastly, how do you combine multiple transformations together? So suppose I had a very simple example of a simple class, which has one method in there. And there are two transformations that I want to do. First one is to change the visibility modifier of this class from public to private. What I also want to do is to be able to remove this method here called print greeting. So how do I do that? So the way that you do that is so this is the result that I want when my plugin runs. And the way you do that is similar to before. We have defined our plugin like this. We have named our plugin called compose transforms, and it has a meta method in there. And I'm going to say find this class called simple class. Again, this could be something much more generalized based on your use case. And then I'm going to say, I want to change the class visibility. How do you change the class's visibility? One way to do it, I have created an extension here on compiler context. And the reason why I'm creating these extensions is just for making it clean. So it takes in a number of params. The KT class is the class that I found. So then what I want to do in here is to change the visibility, is to use the replace transformation, which takes in basically a context. And it also takes in basically an argument called new declaration, in which I have made it private. And as you can see in the string template, in order to convert the string template to a type that we could work with, is I've used this synthetic scope and .class method calls. Variables. So the next transformation that I want to apply is basically I want to remove the greeting method. And the way that I'm going to do that is very similar to what we did before. So this is also an extension on compiler context. And the transformation that I want to do here is declare a new declaration in which I specify what I want to remove. So, and I convert the string template to using expression and method extension. And this will go and find internally like this method, and it will remove it. So I have two transformations: changing the class visibility, removing a method. How do I combine both of them to run together? So there is a plus operator that this library provides. And what it does is that it takes in the plus operator two transformations, and then it creates a new transformation called many. And as the name suggests, you could have an array list of any number of transformations you want to combine. In this case, it's two. So when I combine my transformation, it will go through all of them, and then it will run them on it will go through all of them, run it on the source code. And when I run my plugin, you'll see, the expected outcome where the visibility is private and the method has been removed. So this is a very simple example of how to, combine transformations together. So this library, so we went over each of these with different ways to do source transformations, and this is very, very useful. So now let's look at how do you specify a custom type checker. So before I do that, so to summarize what we just went over, we looked at different ways to write plugins. So looked at simple examples, how to test them, and how to do source transformations on with your plugins. So as you saw before, I spoke about that. There's an analysis and a type resolution phase. And what I want to do is suppose I want to specify some custom type checking logic. How do I do that? So suppose like you're writing your program and you have two custom types defined, and you want to specify the meaning of like when are they equal? What does it mean to subtype one over the other? When is it not right to subtype them, etc. So there are use cases for this, like for example, if you're working with units, etc. So the way you specify a type checker, so we're going to create a plugin just as we did before. We have our meta method here, and I have my name of my plugin, custom type checker. So this is the mechanics you always do for creating plugins with our meta. And there is an extension that they provide, a method they provide called type checker, in which I can inject a class. And this is a class I made called custom type checker, and it takes in the context, which is the configuration of the compiler plugin. So, and then I'm going to inherit a class called new Kotlin type checker. This class is given to me by the Kotlin embeddable compiler dependency. And basically what this class has is two methods that I'm going to override. The first method is to declare is subtype of. So this method gets in two parameters, a subtype and supertype. And I could specify like it returns a Boolean, like when is it right to subtype these two things. So it also has a method to override, to specify a meaning for equality. And you get the subtype and supertype for that. So you could, like, for example, with this, like if you're playing around, you could redefine what equality means. It will run basically these methods whenever as you're writing code in your IDE, and you're doing comparisons, subtyping, etc. So there are examples of plugins. The Arrow Meta itself has a lot of plugins that it comes with. It has a plugin called Type Proofs, which has an example of a custom type checker. In the communities, there's a person who made a plugin called Refinement Type Plugin, which is for a plugin for working with the units, like imperial units, metric units, etc., that you could look at. And I'll provide links in this presentation for those examples. So lastly, what I want to look at are IDE plugins. So how do you, with IDE plugins, how do you bring, experience into the IDE? So you wrote a library, but you also want to add in some developer experience as people are working with your API. your library or your architecture. So this was very useful to me, in my usage of error meta. Suppose like you have some form of an architecture, it could be an MVI, MVP, or MVM, and you define some API for your architecture, but you also want to like improve the developer experience as people work with it. So in here, suppose like I have a view model and I have a method called set state, which refreshes the state, sets the state for this feature. And in my goal is that in the IDE, I want to display an icon whenever this method is called. So how do you write a plugin to do that? So the way you do it is that it's a little bit different than a compiler plugin, where in here you have you're creating a variable which has a type called IDE plugin. And IDE plugin is similar to a CLI plugin, but it's a little bit different. The context is different. It's IDE context. But it's the same way you create a plugin object by providing the name of the plugin, MVI plugin, and then you specify some, just similar to compiler plugins, some extension phases, things that you want your compiler to do, hook into the Kotlin compiler. I'm going to do that in the meta method, same as the before. And then I'm going to say there's a method called add line marker that allows me to specify an icon to display. And the way that works is that I provide the path, the resource of the icon that I want to display. I want to display this icon for a KT name function. And when the person hovers over their mouse on the icon, I want to provide some context as to what that action will do. That's what this message is for. And then I want to do a transformation. I want to specify some criteria. So I want to show this icon for a method whose name is set state. This could be something more general in your use case. So this is a very simple IDE plugin that shows an icon when I call a set state method. And the way you register this plugin is the same way as before. You create a meta plugin object and you register it using with a list of MVI plugin, right? A list of IDE plugins. I think you could also combine them together, compiler plugins and IDE plugins here in this list. So when I run this plugin, you'll see that it does display the icon when I update my state in my architecture. And when the person hovers over the mouse, you can also see that it will show you some message on what this action will do. So, there are plugins that you can look in error meta examples, which make it easier to do monad comprehension, lensing. Lensing is big, especially when you have an MVI architecture. And it also there's a plugin called type proofs that you could look at. So I wrote a blog post on everything that some of what I covered in my presentation on how the mechanics of writing plugins with this library. I found this library to be very useful to building tools for a team, and building tools to people, make it easier for people to use your architecture, your library, improving the developer experience with IDE plugins. So lastly, I want to thank the Arrow team and everyone who contributed to the Arrow library: Rachel, Raul, Imran, Simon, and all contributors who made this library. And if you have any questions, in the Kotlin Slack community, there is a compiler Slack channel I made, and there's so many people that are in there since I made that Slack channel. And you could ask questions also in error meta Slack channel if you want. These are some resources that I'll link out. I wrote my blog post. There are also presentations by other people who have given presentations at Lambda World and on error meta that you could look at. And Raul gave a presentation recently on type proofs that you could look at. So that's my presentation. I hope that was useful to learn about this library called error meta. It's still in development. There are a lot of things being added. So I hope that was useful for you. Thank you. So now it's time to look at questions. We have a question from Mario. who says, I have worked with annotation processors with Kotlin Poet, and it seems that error meta is how it could be done easier. Is there any reason someone should stick with annotation processor because of some limitations of error meta? Yeah, I don't see any limitations. Also recommend asking that question also in the error meta, Slack channel. You get a lot more answers than me, also from contributors. So uh, there are no limitations. Error meta does make it easier to generate code, to hook into the compiler. Has it's a lot more powerful tool. So that's my answer. I hope that's a good answer. But if you want to learn more, I recommend asking that in the Kotlin's error meta Slack channel. Would you recommend keeping your meta plugin definitions in a project? I'm not really sure what's that. So error meta definitions in error meta plugin definitions in a project. So I'm not sure what that's referring to, but yeah, if you want to ask in the Slack channel, then I could answer that more. So yeah. So next question was, any issues with error meta with any obfuscation tool? That's a great question. I don't know. I don't think there might not be issue. That's a good question, but I don't know that. Mario here asking really great questions, and I don't know if it has any issues with obfuscation tools. So those are all the questions. I hope this was useful.